Exercise 10.1 10 the 7 sum is a very important 10 mark question. The first thing that I would request is just because the sum has some complex powers like x to the power of alpha minus 1 or e power minus beta into x power alpha, do not get scared. So that is my first advice that I would give you before you start this sum. Many sums which look complex have very simple solutions. So let's get started. This is a very important sum. It's come in many public papers you would have seen. It is in exercise 10.1. So they have given the probability density function of a random variable x, okay, and x is greater than 0. Therefore the limit is between 0 to infinity. So you have to do two things. You have to find out k, right? And the next thing, you have to find out the probability when x is greater than 10. So the first thing that we will do is, what is a rule if it's a probability density function? You know that between the limits minus infinity to infinity, f of x dx should be equal to 1, right? That is a rule. So that's the same thing we're going to apply here, and our limits is going to be between 0 to infinity, right? And what is the value of f of x? It is k into x power alpha minus 1 e power minus beta x power alpha dx. Okay, how are we going to integrate this? So obviously it looks complex now. So whenever you have such a complex equation to integrate, you split it into simpler ones, right? So what I'm going to now do is, I'm going to take this beta into x power alpha as in smaller variable t. I'm going to say t is equal to beta x power alpha. Now let's differentiate it. You will get dt is equal to alpha beta x power alpha minus 1. Why am I writing x power alpha minus 1? Of course you have a dx here. Okay. If you take any, say I have an x power 4 here. What happens when I differentiate it? It becomes 4x power 3. That is, we write the 4 as it is and subtract the power here, right? So that is exactly what we have done here. We have written this alpha as it is over here, and we have decremented the alpha by 1 in the power. Okay, so you get dt is equal to alpha beta x power alpha minus 1 dx. So x power alpha minus 1 dx can be replaced as dt, right? So let's try to substitute it over here. So we get all this. Don't forget to put that 1 here from this part. So you get 0 to infinity. Let's take k outside. X power alpha minus 1 and dx can be replaced as dt by alpha beta, right? So I'm going to write it as dt by alpha beta, and e power minus x power alpha beta x power alpha can be written as e power minus t from here, right? It's equal to 1. Now let me write it more neatly. So it will be k by alpha beta. Alpha beta is a constant. I'm taking it away. E power minus t dt is equal to 1. I'm not supposed to write these limits as it is because these were the limits of x. Now we are replacing x with t, right? So now let's see what happens to x when, what will be the value of t when x is 0 and infinity. When x is 0, what will be the value of t here? Obviously 0. Likewise, you substitute it in this equation. Likewise, when x is infinity, obviously it will be infinity again. So the limits actually remain the same in this sum. But whenever you are substituting like this, do not forget to change the limits, because the limits given in the sum will be with respect to x. But when we are changing it with respect to t, we have to change the limits accordingly. But for this sum, it's not a big deal, right? So let's continue with this, right? So What is e power minus t dt? It is nothing but k by alpha beta. E power minus t is nothing but e power minus t by minus 1 between the limits 0 to infinity. We'll just take the minus sign outside. So minus k by alpha beta into upper limit. So e power minus infinity is going to be 0 and e power 0 is going to be 1, right? So of course this is equal to 1, right? So this gives us minus k by alpha beta into minus 1. So plus k by alpha beta is equal to 1, which means that k is equal to alpha beta. So this is what we had to find out, right? The first part of the sum was to find k. It is done. The second part is to find the probability for x greater than 10, right? So the probability when x is greater than 10 can be written as limit 10 to infinity, because x is greater than 10. So between 10 to infinity, f of x dx, where f of x is nothing but, it is this. Actually it is the same as given in the sum here, but only thing is we have replaced k with the alpha beta that we just found out over here, right? So this again looks as it's a very complex equation, but same logic. Substitute beta x bar alpha equal to t, and as we did earlier. So let me do that for you. So what we are going to do here is we are going to say let t is equal to beta x bar alpha. So my dt is going to be equal to alpha beta x bar alpha minus 1 dx, right? So now substitute this. Let's come back to the limits a little later. So between 10 to infinity, it is plainly going to be e power minus t dt, because alpha beta x bar alpha minus 1 dx is replaced by dt, right? And of course this becomes e power minus t, right? And now what happens, these limits we can't write here, right? So we have to know what the limits are. So let's write it down for x and t. So what is the limit when x is 0, and what is the value of 10, not 0, 10, and what is the value of t when x is infinity? So what would be the value of t when x is equal to 10? Substituted in this equation, you will have beta 10 power alpha, right? And then when x is infinity, obviously t is also going to be infinity. So your new limits would be between beta 10 power alpha and infinity, right? E power minus t dt, right? Now you know that e power minus t is e power minus t by minus 1 between the limits beta 10 power alpha and upper limit is infinity. So for convenience sake, I'm going to take this minus 1 negative sign outside. So it is going to be e power minus t between the limits of infinity and beta 10 power alpha. Now the upper limit e power minus infinity is going to be 0. Upper limit is done. Lower limit is e power minus beta 10 power alpha, right? And this only for 10, of course, right? And you close it. So you can just write the final answer as probability of x greater than 10 is equal to, minus into minus is plus, so you can straight away write it as minus beta into 10 power alpha. Got it? That's all. You can leave it over here. So this completes the second half of the sum. So first half of the sum, you found out k, substituted the value of k, and for limits 10 to infinity, using the same logic, you have found out the probability of x greater than 10. So actually if you see, this is a very simple sum. You just have to remember to substitute beta x power alpha equal to t. If you do that, then the sum is easy to follow. So you can just have a look at the sum.